But we are at our discussion period, so we can sort of pull in some of those older questions. Thanks, Eileen. We can leave your questions up as inspiration. There was a question, let's see. So there was a question, I think that Ryan briefly responded to about if van der Waals forces, I'm not sure which talk this came up during, but it was a question about whether van der Waals forces relate to dust particles clinging to each other when in close contact. I think related to some of the, I don't remember which talk that was related to, sorry. And I think there was a question about van der Waals forces earlier. There has been a decent amount of work looking at the relative role of van der Waals forces versus other contact surface forces and other longer range forces. There's a few, mostly modeling papers that have been done to sort of compare the relative roles of those. I don't know if anybody's looked at it specifically for like the South, like specifically the geometries and stuff for the South Pole. Let's see, there was a question for Mihai earlier about the enhanced dust density over the Dawn ? Terminator shown during your LDEX talk. What is the current explanation for that? I don't know if Mihai is still on. My WebEx is being very laggy.
I'm here, Eddie. Can you hear me?
Yes.
So the asymmetry, of course, is first of all, the motion of the moon around the Earth. That 1 kilometer per sec, in addition to the 30 kilometer per sec of the Earth around the moon, is sufficient to modulate the impact speeds that we see that in the surface density as a function of local time. Then the other issue is towards and away from the sun asymmetry, because the fluxes of Helian and anti-Helian sporadic background should be similar. So I think what we see there is the contribution of beta meteorites. These are small particles driven from the direction of the sun by radiation pressure. And by 1 AU, even though they are very small, but they are really fast, 100, 150 kilometer per sec. So they can be very efficient of generating ejecta. So the left-right asymmetry with respect to the motion of the moon is probably due to the contribution of beta meteoroids.
Thanks, Mihai. I can't do this first. Okay, well, Q&A is being very fun for me right now. I think it's my computer. I think that there had been a question earlier also about using nuclear power on the lunar surface, but I'm not exactly sure who to address that to. And if you can't type in the Q&A, feel free to type in the chat. We're checking both.
Yeah, I think the chat's working slightly better.
And if anyone wants to ask their question verbally, just raise your hand and we'll unmute you.
Thanks, Ricky. Let's see. Okay, let me find. There was also some discussion in the chat between that Rebecca Gent answered for Jeff Gillis Davis, had asked, can Diviner see any thermal effects around Apollo landing sites, such as the Saturn 4B impact sites or other impact sites, such as Grail? I know it saw L-Cross shortly after impact. Was there no permanent thermal effect? I don't know if either of you wants to chime in any more about that, or if Ben Greenhagen is on, if he wants to chime in.
Yeah, so my response to Jeff's question is just been that I'm not a diviner person, so I don't look at diviner stuff often. That I believe the diviner footprint is going to be too large to pick out thermal effects around the old spacecraft landing sites. But again, it sounds like Ben's probably looked at it possibly more.
Yeah, this is Ben Greenhagen. Yeah, the Apollo sites and those impacts are just really too small for us to resolve in any kind of reasonable way. We do see these thermophysical anomalies around the largest of the recent impact craters. So the 40-meter and larger impact craters do have noticeable effects. With regards to L-Cross, we did observe for about 8 hours after the impact a thermal signature, but after that it had faded to background.
Thanks, Ben. Okay. Oh, I can scroll now in my Q&A again. There was the question was from Mike Drever about why are closed nuclear heated systems not allowed? I assume this is a question for somebody about the sources. Ron says he can maybe answer that question. Go ahead, Ron, if you're able. And if anybody else has a question and wants to just jump in, also feel free.
Ron, I can address the nuclear question. Can you hear me?
Mm-hmm.
I've continually pointed out that nuclear is the ultimate answer for surviving the lunar nights. However, there are issues with that, and even up to the safety of the crews. They did take radioisotope fuel cell rods and activate those for the Lapuno.
I don't know. I think we got cut off there. Or maybe it was just me. Ron, did you?
I think we all lost it for a second.
Okay, I think we all got muted.
Did you hear me? I said that it's not politically possible anymore. It is the ultimate solution for surviving the lunar night, but it's not going to happen. The Russians had it on their systems. The Chinese have, but for us and for ESA, my friends in ESA, they say they can't do it either.
Okay. Thanks. I think George had a question.
Right. Can you hear me?
Mm-hmm.
Yeah, great. So I've been working on dust with folks on the same group that was reported on earlier by Joel Levine for several years. And one of the questions that, and I've worked with the van der Waals forces with Gecko Materials with the guys at JPL on the phone with them about understanding electrostatics versus van der Waals in their efforts to do Gecko materials. And there appears to be a point where van der Waals takes over, where electrostatics, can't overpower it. And so if that's the case, what sort of not just modeling but testing been done to show how that affects things like dust clumping or dust lofting and our ability to mitigate it when it's sticking, especially the very small ones that you can't see, let's say less than 10 microns. And if they are sticking with van der Waals forces, then perhaps the mitigation for those is not electrostatics, but perhaps an alternate van der Waals sticking force. And that's where I'm going with that. Yeah.
I don't know if Shu Wong wants to chime in a little bit here. So it's an interesting delineation, right, between all of these different types of surface forces and what's actually creating the sticking forces. Van der Waals definitely can dominate at so there's a very short range force, right? So they can dominate when you're talking about the actual intergrain interactions, and they're often sort of distinguished between I think a lot of things get lumped in as van der Waals forces when we're talking about those surface forces. Most of the time when electrostatics and the electrostatic dynamics modeling is done, it's looking at sort of the behavior of grains, probably once they've already separated. But there are a number of experiments that have been done. So she's done a lot of them, and that are that other folks, like the folks doing the Lotus coatings, right, have done, to look at some of the relative roles of those forces.
So yeah, can you hear me?
Mm-hmm.
Okay, so yeah, just follow what ID said. You know, if you remember in my talk, there's a slide we show dust, lofted. And those lofted dust, I can tell you, they overcome the adhesive force or cohesive force, which is much larger than the gravitational force. So there definitely can be overcome. And also we're working on this to mitigate dust by doing electrostatic charging and repelling. And so we have a paper just published. If you're interested, I can route to you. But I can tell you, yeah, the electrostatic definitely can overcome adhesive force.
Van der Waals forces.
Van der Waals forces, what you call it.
And what size particles?
Oh, those from, very small micron, submicron to large, like, 20, 40 microns, all the ranges.
Cool. Yeah. Some guys at JPL would like to see that too. So, yeah, george.f.studer@nasa.gov.
Okay. Yeah.
Thanks.
Yeah, I think, and one thing with that, right, is that a lot of times, like Shu or I will often just say like adhesion or cohesion forces, and not specifically say them as van der Waals forces. There was an interesting paper Christine Hartzell did a little while back, looking sort of at that relative effect to some extent too. And yeah, Shu can send you some awesome new papers.
Thank you.
And I think, and also with what Shu said, right? Like, even if it is van der Waals forces that are creating some of the sticking, if there are ways to use electrostatics to overcome that, that's an interesting solution. So, but I think now we are going to transfer into our breakout discussion, into our break, as we go into breakout discussions.